Hi, welcome. In this video, we will solve problem next greater element type 2 asked by companies like Amazon, Microsoft, Facebook, Google, and some others.
So let's check out this problem. Next greater element type 2. So I hope you have solved all the four types that I have discussed in the previous problem. That is nearest smaller element, okay, from left. That basically I have covered in the lecture. We have nearest same smaller element on the right side, okay, and then we have next greater on the left side, and then we have next greater on the right side. So yeah, these were the four problems that you should solve and then jump to this problem, okay, because this is a variant of these four problems, okay, and these four are must to solve. So now let's quickly start. What is this next greater element? Given a circular integer array, that's a h here. So instead of normal array, one circular integer array nums is given, okay, that is the next element of the nums of nums dot line. That means the next element of the last element is the first element, okay, and we need to return the next greater number for every element in the nums. The next greater number of a number x is the first greater number to its traversing order. So basically a number that is greater than to a number in traversing order will be the next greater, the first greater, okay, which means you can search circularly to find its next greater number. If it does not exist, return -1 for this number, okay. So here you can see for 1 to 1, okay, so for 1, what is the next greater? So we have 2, so that's why the answer is 2. For a 2, if I search from here, okay, through a complete doing a circle, right, even till here, okay, I'm not able to find any number that is greater than 2. So that's why we have -1 for it. And for 1, so we don't have any number that greater than 1 here, but this is again a circular array. So we have here, that is 2. So that's why the answer is okay. Similarly, if I talk about this one, so for 1, the next greater is 2, so that's why 2. For 2, the next greater is 3, so that's why 3. For 3, the next greater is 4, so that's why 4. But for 4, if I do a even circular rotation, I'm not able to find any number that is greater than 4. That's why -1. For 3, there is no number greater here, but if I'm doing a complete rotation, right, a complete circular rotation, I'm able to find a number 4 that is greater than 3. So that's how all these are outputs. Okay. And now let's see one by one how we will solve this problem. Okay. So first of all, let me take that example, similar example that we have 1, 2, 3, 4, 3. And let me quickly write the indexes 0, 1, 2, 3, 4. Suppose this is it. So yes, how we will solve this problem? Okay, this is my array and I just need to find the next greater element. Okay, so the very basic approach of brute force for this problem statement that can be is what I can do. Okay, we say as approach 1, that is simple brute force. So basically for this element, I want to find a greater element on this side, right? If I am not able to find it, I will just traverse from here. So let's suppose I have one as such number as 4. Okay. So for 4, I will find the next greater element from here. Okay. So I will traverse from here and I will traverse then from here. Okay. So basically I am saying that suppose for 4, okay, for a number 4, okay, you will traverse from, suppose, for from index of 4, okay, simply write from index of 4 to the last, okay, that is already the last, to the last, and then you will start one loop from the starting, right, from index equals to 0 to that is your index 2. Okay, so basically we will traverse in one single direction, right, from here, and then we will traverse from here. So let me write a pseudo code for it. So what we can do here, how we can solve this problem. So that what I will do, I will take one element. So suppose we'll start the loop of from I equals to 0 to I equals to n minus 1. Okay, this will be my loop. And why this is my loop is basically I'm picking one by one all the elements, one by one all the elements, right? Now for each element, what I will do for each element, I will find out from j equals to I plus 1 to n minus 1 if there is any number, okay, if there is any number jth element that is greater than my ith element, that will be my next greater. Okay, that will be my next greater. So what I will do, I will simply say create one array as answer. Okay, and I will push answer dot push array g. Okay. But there is, can be a possibility that you won't be able to find here. So what you will do, you will like run a circular, right? So what you will do, you will start from j equals to 0 to j equals to I minus 1 before it. Okay, and again you will do the same thing. You will find if any element of jth, okay, that is greater than your ith element, so you will push inside answer dot push array g, right? But here you just need to be a bit careful that you are starting from here, but you don't need to push two elements for the same number, right? So suppose just after pushing you can make something as flag equals to true. Okay, and you break it here, and this loop will only run when flag is equals to false. Okay, then this will run. So you will start from here with flag equals to false. Okay, you will make it true and break it. Once this is also completed, you can break it. Okay, and in the last we will return answer as our final array, right? This can be one approach that we can apply. Okay, again, very one brute force approach. Apart from this, let's see first of all, let's understand the time complexity of it. So we are running one iteration, one traversing from 0 to n minus 1. Okay, that is surely going to take n iterations. Okay, then I'm starting from I plus 1 to n minus 1. Okay, so this is will take roughly around n minus I iterations, right? N minus I, and this is from 0 to I. So it will take, I will say, I iterations. Okay, and if I complete like both, sometimes for some of the you can take suppose worst cases, what it will do, it will both will run. So n minus I plus I. Okay, so that is also a complete n iterations. So n iterations on the parent loop, n iterations inside it. Okay, and there is a complete relation of it, right? For each ith, j will start from, j will do perform n operations, right? So what will the time complexity here? That will be big O of n square, right? N into n, that is n square, and space complexity. So we are not taking any extra space apart from this answer array, right? So for this answer array, it will be big O of n, and this will be my solution to this problem. Okay. Now, any other approach apart from this, how we can solve it a bit more promptly, right? Without using these all loops. So let's see. So how we can solve this without taking that much loop? Let's see, let's understand it. Okay, so discussing the second approach, what we can do here. So let's understand again the problem statement. What I want to find a number next greater to it for 3. Okay, but I just like I will do a circular rotation, right? I will do a circular, I need to do a perform a circular rotation for it. So what I can do, can I write all the elements that are before it here? Again, this is all dynamically, right? We are not going to double the array, but we will visualize it doubly, right? We will double it in a sense, but we are not basically doubling the array. The size of the array will still be remain n. Okay, what is the size here? The size of the array is of 5 elements, right? What I will do, I will simply put 1, 2, 3, 4. Yeah, these all elements. For this last element, we want only these elements, right? So let me write the indexes of it. 6, 7, 8. Okay, and if I'm doubling the array, let me write this one as well. Yes. So basically what I did, I basically doubled the array. 1, 2, 3, 4, 3. 1, 2, 3, 4, 3. Okay. Again, this is for visualization. We are not double the array. Again, the size of the array will remain n only. Will remain n only. Okay. I'm telling you how we can solve this. So now see what we will do. So what we will do. So see what I need to do. I need to find next greater element. Okay. Next greater element for all these five elements only, right? 5 elements. We have doubled the array, but we are not going to find the next greater for these elements. So we need to find for these elements. So what I will do, I will pick one element. For this one element, okay, I will iterate from here, that is next to it, to the last element. Okay. So suppose this is my ith element. I will start from this and I will run till last element. Okay, but for this, like for one, we can go till here only because we will get the answer. So like suppose my total iteration will start from I to I plus n minus 1. Okay, so how this will work basically, so for this element we will iterate this only, right? Because this will give us the answer, but not for this, right? So when I is here, at the last, I will run till I plus n minus 1. What will be I plus n minus 1? That is 4 plus 5 minus 1. That is 4 plus 4. That is 8, right? So what I will do, I will traverse till my 8th of the index, till here. And I will able to find the next greater of it. Okay, suppose my I is here. So what I will do, I will traverse from here, okay, till here. So in this case, we don't need to again start one loop that is starting from 0. Okay, we will find it here as well. Okay, now, now, now basically how we will find it, what we will do. So see, basically here this is 4. Okay, here why I'm saying that we won't double the array, but we will get it. Here it is 4. Okay, when my I will become 5, 6, 7, 8, it will give me the index out of bound, right? Or the element is not present, right? Basically, there is no element that is of index of 5 because the there are only 5 elements, right? So what I will simply do array I modulus n. Okay. So if I'm doing 5 modulus n, what is 5? So 5 modulus 5 will give me 0. So my I will increase, right? My I will be 5, but it will pointing to 0th element. When I will be 6, 6 modulus 5 will give me 1. So it will pointing to one element, right? Like one index. Then 7 modulus 2, 7 modulus 5 will give me second index, right? So we are moving ahead. Okay. But we are finding only the elements that are present in the air, right? So basically you can see 5 modulus 5 will give you 0. So you are pointing to 0th index. Then 6 modulus 5 will give you 1. You are pointing to 1 index. 7 modulus 5 will give you 2. So you are pointing to second index, right? So you are moving ahead, but you are finding the elements in the array itself. Okay, let's quickly see what will be the brute force of it. So basically, I will start my loop. That is, I will start my loop that will start from I is equals to 0 to I equals to n minus 1. Okay, basically I will find all the next greater element for these set of elements. Inside it, I will start my loop that will start from I plus 1, just next greater, to j equals to I plus n minus 1. Okay, like I to I plus n minus 1, right? Because I need anyhow I need to find n elements, right? Anyhow I need to find n elements. So I will iterate to n elements, right? So I plus 1 to I plus n minus 1. So this is a journey of n elements. This is a journey of n elements. Okay, so this is done. And now during this iteration, if okay, so here it won't be array G only, right? What I will do, I will convert it. So what my J is equals to I plus 1, J will be somehow 7, right? So what I will do, I will say suppose index equals to J modulus n, right? And then what I will do, I will say if my ARR array of index is getting greater than array I, that means this is my required element. This is my required element. Okay. So what I will do, I will simply push in my answer dot push array again index. Okay. I will push it and I will break it. Okay, and yeah, that's it. This is how you will able to solve it, like this question. Basically, you created one answer array, you are starting from 0 to n minus 1, only the 5 elements. Okay, but on each iteration you are starting from I plus 1 to n minus 1 with taking this as a concept j modulus n. Okay, and whenever you find it, push it, then break it. Okay, so what will be the time complexity of this approach? So here we are traversing for n times, right? N iterations will be there, 0 to n minus 1. Okay, here I am traversing from I plus 1 to n minus 1. That is also like n elements, right? So basically n iterations here. So again the time complexity will be remain same, that is we go of n square. So the time complexity of this approach will be big of n square, and space complexity will be big of n by taking answer array. So it will be big of n. So again here we have optimized the approach, but still the time complexity will be same, and your interviewer might not be happy with your answer, right? He want you to optimize it more further. So now let's see a bit more optimized version of it. So let me mention that approach 3. Okay, this is my third approach, and how I'm going to solve it. Again, what we need to do, we need to find the next greater element of. Okay, so now we know, right, the what is the concept that we basically solve using stacks, right? Using stack data structure. Okay, if you solved my all the problems, we have solved it by using stack. We don't need to traverse for the all elements when we are using stack. Okay, so let's quickly understand it. So here, this is my stack. Okay, and now let's solve by using stack. So this is next greater. Okay, next greater element. So how to find the next greater element? Okay, by using a stack. So basically we will traverse from right direction, right? From here we will traverse from the last element, right? When we are finding the next greater element. Okay, so see, for 3, is there any next greater element to the right of the side? Okay, let's forget the circular array first. Let's quickly revise the concept of next greater. So is there any element that is greater than 3 on the right side? No. Okay, and how you will get to know that? Because your stack is empty, right? Your stack is empty, so you will say simple -1. Now you will move to this one. Is there any element that is greater than, and like before moving, you will put 3 into the stack. Now, is there any element that is greater than 4 on the right side? Okay, so what you will do for it, you will find out in stack. Is stack is empty? No, it is not. Stack is not empty. So if the stack element is greater than 4, no, it is not. So what you will do, you will say, I want greater elements on the stack. I want greater elements only. So you will remove it, and now the stack is empty. So you will say -1. Okay. And before moving ahead, you will put 4 into it because that can be a next greater for the next element. Okay. So for 3, you will check, is your stack is empty? No, it's not. Then you will check, is the element present in the stack is greater? Yes, it is. So you will say, yes, that will be my required element. And before moving ahead, you will put 3, push into 3 into the stack. Okay. Now you will check, is the stack top element is greater than my required element? Yes, it is. So yes, that will be an answer. Okay. Before moving, you will push 2 into it. And you will check for 1, is the top element is greater than your answer? Yes, it is. So you will simply go to and you will simply move. So this is how you can solve next greater element, right? Basically traversing from the last element to the first element and by using stack. Okay. But this, okay. Now for the circular array, this problem, what is the problem that you should not get -1 here, right? You should get 4 here. Why 4? Because here, if you traverse in a circular direction, you will be able to find this element, right? Okay, so why we are not able to find it? Because there is no element here, right? There is no element here. So what we can do? What we can do? Again, we will create visualize it doubly, right? So we will create a double the array. We will again double the array. So if I double the array, how it will be like 1, 2, 3, 4, 3. This is my double the array. And if I mention the indexes with some white color, suppose 5, 6, 7, 8, 9. So what I will do, I will double the array. Okay, again we are not doubling the complete array, right? We are again visualizing it. We are visualizing it, but we are doubling the array so that for this 3, there should be some greater elements on the right side. That was my problem. For 3, I was not able to find any greater element on the right side. That's why I doubled the array so that for these elements, I should able to find the greater elements on the right side. Okay, so what we will do, okay, now we will again do the stack things, right? So what I will do, I will say I will start from the last element. Okay, for 3, is there any element that is greater than that? So no, it's not. Okay, stack is empty, so it should give me a result -1, right? It should give me a result -1, but this is not the actual element that I'm going to find, right? This is not the actual element. So what I will do, I won't store the answer, I just maintain the stack, right, my stack. There is no answer, right? I won't do anything. Okay, and before moving, I will simply mention 3 in my stack now. So now 4, is 3 is greater, is 3 the topmost element of the stack is greater than that? No, it's not. So what you will do, you will pop it out, you will pop the element. Okay, and now the stack is empty, so the answer should be -1, but that is not my actual element. Okay, so I won't add it to my answer. Okay, I will just fill my stack. So before moving, I will fill the stack with 4. Okay. Now is 4 is greater than 3 in my stack because 4 is the topmost element. Is it greater? Yes, it is. So that will be my answer. Okay. But again, this is not an actual element, so I won't fill it and I will move it. Before moving, I will put 3 in my stack. Now for 2, is the topmost element of the stack is greater? Yes, it is. Right. So this should be answer, but we are not doing it. So we will simply add 2 and move forward. Similarly, for 2 is the greater, so 2 is the answer. We will simply add 1 and we will move it. Now here my actual element comes, right? Here my actual element comes. I will start filling from here itself, right? So for 3, is 1 is greater? No. So what I will do, I will pop it out. So for 3, is 2 is greater? 2 is the topmost element? No, it is not. For 3, is 3 is greater the topmost element? No, it's not. So what I will do, I will simply say, I will simply pop it out. Now for 3, is your topmost element 4 is greater? Yes, it is. So yes, 4 will be my answer. Okay. And again, before moving, I will push 3 into it. Okay. Now for 4, is 3 the topmost element is greater? No, I will pop it out. For 4, is topmost element 4 is greater? No, I will pop it out. And now my stack is empty, right? So can I say, I will say -1? Yes, I will say -1. Then I will check. For 3 is stack. There is nothing in the stack. And before moving, let me push 4, right? Before moving, remember, we need to push 4. So for 3, what is your topmost element? 4, which is greater. Yes, so this will be your answer. Yes, it is. This will be my answer. Okay. Once I mention it, okay, I will move to the next element, and before moving, I will push element into the stack. So for a 2, what is your topmost element? 3. Is it greater? Yes. So that will be your answer. Okay, you will move it. Before moving, you will push element in the stack. For 1, is the topmost element is your answer? Yes, 2 is greater than 1. So 2 is my answer. Okay. Again, before moving, what I will do, I will push 1 to stack. And these all are my required elements. Okay, this is my required answer. So I am able to find the answer. Okay, I'm able to find the answer. Basically, what I have done, I have doubled the array. Okay, I am taking elements these, but I am not filling my answer array because these are not my actual array, but I'm maintaining the stack. So the whole concept is you are maintaining the stack. Okay, so how we are solving it? What will be the code for it? So the pseudo code will be exactly same that you find out in the next greater element. Okay, so what I will do, I will suppose I will create one variable that is the stack. Okay, this is my stack, and again one answer array. Okay, you can create a answer array to up to nums dot length, or you can push it. That's up to you. Okay, so what I will do, I will simply start one loop. Okay, and I will start 2 into n minus 1. Why 2 into n minus 1? What will be 2 into n minus 1? N is here 5. Okay. So 2 into 5 minus 1, that is 5 to 10 minus 1, that will be 9. And I will be at here, right? This is what I want. I want to be at 9 index, right? So I need to start finding the next greater from the ninth of the index, right? So I will start from 2 into n minus 1, and I will go till I greater than equals to 0, and I will do I minus minus. This is how I will solve it. Okay. And right, how we will basically solve while, right? Why when we need to pop out when the element is not greater. Okay. And when the when stack is not empty. So I will say when my stack dot length, okay, first of all, it should not be equals to 0. Okay. And if my stack dot my last element, if my stack topmost element, let's say stack topmost element is lesser than or equals to my current element, okay, then there is no need to be present in the stack. What I will do, I will simply say stack dot pop. Okay, remove from the stack. Okay, now when I'm coming from here, what will the two possibilities? Either one possibility is, okay, that your stack length is 0. Okay, I will come out of the loop when my stack length is 0. If my stack length is 0, what I need to do? I will simply say answer of I equals to -1. But there is no as such element. Okay. Else what I will do? Else what I will do? I will simply say answer of I. Okay. Now the next possibility is you are coming from the stack because the topmost element is greater than array I. Okay. So if it is greater than array I, what you will say that answer of I equals to what will be your topmost element? So can I say stack of top? Yes, that will be. And what you will do, this will be your answer. But here is a catch. This will we will do only when we have the actual elements. So when my I is less than n, then I will follow this. Then I will follow. Then only I will follow this. then only I will follow this. And again, before moving here, also I will simply do stack dot push array I. Right? So before push, this is how I will able to solve this problem very easily. So you can see we are filling only when we have an actual elements, okay, when we have actual elements. But here there is one catch, one small catch, okay, that this is clear, right? When I is less than n, then you will simply find answer of I, then answer of I you will mention it, right? But you are saying array I here, right? And I will be 8th, ninth. You have not doubled the array. So how this will work? How this will work? So this should not be array I. Okay, this should not be array I. What again? What you can do? What we have done previously? You can create index I modulus n. Okay, and instead of I, you will mention array of index. Okay. So when is 9, 9 modulus 5 give you 4, right? So you will hit this index pointing to 9. So you will add 3. You compare the same element twice, right? Basically, and from 9 modulus will give you 4, 8 modulus will give you 3, and you are iterating in this direction, right? Again and again. This is how you will follow it, and here you will only mention when I is less than n. So this will be here or here. Here as well. Okay, remember here as well because you are pushing. Okay, so it will be I modulus n. So I will say index. This will be the right option. Okay. So yeah, this is how you can solve this problem. What will the time complexity of this approach? So you are running from 2n, right? 2n. So this will take no matter how 2n iterations, right? 2n iterations it will take here this while loop. So no matter what it is, okay, there are different elements also. Your stack will be maintained for only n elements, right? Your stack will only maintain for n elements, right? It won't go to the longest 2n elements. No, not that possible. It won't be happen. It will go till n elements only, even if you are taking worst case of suppose 1, 2, 3, 4, 5, right? Still you are taking if something like this, it will take only 5 elements. Okay, then for this 5 you will find out the data element, so it will pop it one by one. So this will take n iterations only one time, right? So this will take n iterations, and so we don't basically multiply it. There will be 2n iterations plus 1 n iterations in the worst case, so that will be around 3n only. So the time complexity will be big of 3n. Okay, and yeah, this will be my time complexity, and that is 3 is totally fine because that's a constant. So time complexity will be again big of n only, right? You can ignore the constant. And your space complexity. So for a stake, I have said that there will be, no matter what it is, there will be only n elements in the stack, n elements in the stack. Okay, so it's not going to be more than that. So it will be big O of n plus your answer array. Okay, so it will be big O of n here as well, right? So the time complexity will be big O of 2n. Okay, but again you can ignore the constant 2n. It's again the 2n basically proportional to n only. Okay, so your time complexity will be big O of n here, and your space complexity will be big O of n. But remember, whenever you express to the interviewer, always start that it will be big O of 3n. Basically, if your n is suppose 5, so there will be a total 15 iterations of it. Okay, but that is only in the worst case. Okay, that's again a constant, so you will simply ignore it and you can move it. Okay, so the time and space complexity here will be big O of, and this is how we have optimized it. Okay, so in the next video, in the implementation video, we will see how we can apply the approach 3, how we can write the code for it. Okay, so just be ahead to the next video. Okay, we don't discuss all the first and second approaches because that is not going to be an answer. Okay, but for your interview experience, you can share it to the interview that I have come up with 3 approaches, and this is how brute force better and the optimal. Okay, and see you in the next video.